In the last class, in the combined class, we have learned about solution of higher order constant quotient linear differential equations. Let me explain once again the entire procedure. Saying, consider I can say already explained nth order, no? Okay, let me write. Consider the constant quotient linear differential equation. What is that form? F of d into y equal to 0. Constant quotient homogeneous. Homogeneous means what? Remember, this right side function is 0. Homogeneous differential equation. F of d into y equal to 0. Here, what is f of d? I told you already. What is f of d? A0 into d power n, a1 into d power n minus 1, and so on. A n minus 1 into d plus an. This is the operator. An. This is the operator, which is linear. Linear means what? I told you, dependent variables not multiplied together. Hence, f of d can be factorized. F of d can be factorized as d minus d power n. So just whatever, I can take a not common, then d minus something, alpha 1 or m1, say our m1, d minus m1, d minus m2, and so on, d minus mn. F of d can be factorized as f of d. Then what is equation 1 becomes? F of d into y, d minus m1, d minus m2, and so on, d minus mn into y equal to 0. Then how to solve this differential equation means, first you consider this. You consider this as something. Okay, then solve this. What is the structure here? Here, I'm giving a general form here. D minus m into y equal to 0. D minus m into y. Generalization. Instead of m1, m2, mn. If any doubts, you can raise the questions. Is voice is audible?
Yes, sir.
Yeah. Yes, sir. Sir, someone is waiting in waiting room, sir.
See, when I am teaching class, again I have to go to another window. Lot of disturbance is there. If you want to join at the time. D minus m into y equal to 0. Okay, this is the structure of this linear form. These are all linear factors, first degree factors. Then what is actually d minus m into y? Nothing but dy minus my equal to 0. Dy minus my equal to 0. If anybody wants to join immediately. Now onwards, I will start the class if everybody joins. Otherwise, I will not start. Now, what is this one? I will start from here. So what is this is equal to? D minus m into y equal to 0. What is d minus m into y? Dy minus my equal to 0. What is stands for? Dy stands for what? Dy by dx minus my, nothing but my, right? This is variable separable form. I can write 1 by y dy equal to m dx. So integrating on both sides, 1 by y dy equal to what? Integral m dx. That is equal to log y equal to mx plus I will take log c. Mx plus log c I will take. Then that is equal to log y by c equal to mx, isn't it? Right? Log y minus log c. So this is e to the power of. So y by c equal to what? E to the power of mx. E to the power of mx. That is equal to y equal to c into e to the power of mx. Y equal to c into e to the power of mx is the, what is this? Is the solution of the differential equation. Solution of the differential equation. What type of differential equation? D minus m into y equal to 0. D minus m into y equal to 0. Isn't it? Right? Now we have, what we have from equation 1, what we have? D minus m1, D minus m2, and so on. D minus mn into y equal to 0. Got it? That is why from we have equation 1. So for this is the solution. Again you will get something here. Then for that d minus m2 into something is again one more e power mx solution. So what is my aim? Why I am telling this? Because for the differential equation of the form d minus m into y equal to 0, what is the solution form? Solution form is what? Some constant c into e power mx. Constant c into e power mx. Now, so forget about this one. Okay, this equation. Now, f of d into y equal to 0. F of d into y equal to 0. What we consider this f of d is what? Exactly this. This is the f of d. That means it is factorized into linear factors. D minus m of the form d minus m into y equal to 0. That is why when we consider auxiliary equation, okay, why I am telling this? Only the logic is, if auxiliary equation roots are, for example, f of m we consider f of m equal to 0, then roots are what we have taken m1, m2 and so on. Then I have written solution. What is the solution for m1? What is the solution? C1 into e power m1x. For m2, what is the solution? C2 into m2x. Like that I have taken, right? Why this e power is taken when m1 is the root? Exactly this is the reason. Why this? Why? If m1 is the root of the auxiliary equation, what is the solution? C1 into e power mx. C1 into e power mx. Why I have taken this solution? Because this f of d can be factorized into product of linear operators, and this solution of this linear is of the form c into e power mx. C into e power mx. That is why we are taking this solution. Got it? Any doubts? This is the first point. Coming to second point, if any root is repeated, two times, I'm taking only 2 times. If any root is repeated 2 times, what is meant by 2 times? Say m1. Say m1 repeated 2 times. Say m1 repeated 2 times. Then what I have given solution? M equal to m1 repeated 2 times. Then what is the solution I have taken? I have written e power m1x, and what is its quotient is first degree polynomial c1 plus c2x into e power m1x. Why I have to write like this? The reason behind this is, now see, t repeated, m1 is repeated how many times? 2 times. 2 times means what? D minus m1 whole square equal to 0, correct? m1 repeated 2 times means d minus m1 whole square equal to 0. So I can write d minus m1 into y equal to 0. Then assume this one, first one, d minus m1 into y equal to something u. Then okay, let take this as some star. Then star becomes, this is the only idea why I am considering the solution of this structure. For that I am giving explanation. Then star becomes, what is this? D minus m1. What is this entire value? U equal to 0. Then what is this? Is nothing but du minus m1 u equal to 0. Du is nothing but what? D stands for what? D by dx equal to m1 u. Just now I have solved this. What is this? Is 1 by u du equal to m1 dx, integrating and integrating, what we have get lastly solution u equal to what, some constant c1 into e power m1 x. Same logic for this equation. What is the solution? Just now we derived na above. For d minus m into y, this is the solution. Same logic. So I got this solution. Substitute this in what is the equation? This part, star. Substitute this in star. So star implies what? 1 d minus m1 is there into u equal to 0 na, and d minus m1 into what is this u? c1 into e power m1 x equal to 0. Now c1 is constant. This is what? Derivative of d stands for what? Derivative. m1 into c1, m1 into c1 into e power m1 x equal to 0. Isn't it? Right? That is equal to 0. That is c1 into what you will get now. Where is y? In y I have to substitute, not in this one, that is why we are not getting differential equation. I have to get differential equation. Substitute this in substitute this in what, this equation. Substitute this in d minus m1 into y equal to u. Okay, then what is this? D minus m1 into y equal to what is this? Is e power m1 x, isn't it? Right? Now if I write this differential equation, expand this differential equation, I'm getting this one. What is this differential equation? dy by dx minus m1y equal to c1 into e power m1 x. This is what? Double star is linear differential equation in y, isn't it? Right? What is the form? Linear differential equation form. This is what is the linear differential equation form? dy by dx plus p of x into y equal to q of x model. Done. This is q of x, and what is p of x? Minus m1. So what is integrating factor? Integrating factor is equal to what? E to the power of integral minus m1 dx minus m1 dx minus m1 dx, that is e to the power of minus m1 x. So solution is what? Y into e power minus m1 x equal to integral c1 into e power m1 x into integrating factor dx plus some another constant c2. So y into e power minus m1 x, this is c1 outside and this is 1, so I will get c2. Then what is y of x solution? c2 plus c1x into e power m1x I will get. Exactly, see, repeated 2 times I have written. What is that? If m1 repeated twicely, m1 repeated 2 times, solution is what I have written. Solution is c1 plus c2x first degree polynomial into e power m1x. Both are same, just constants are interchanged, doesn't matter. Okay, this is the reason when repeated 2 times. Same logic when repeated 3 times, when m1 repeated 3 times, then write e power m1x, and its quotient is a quadratic expression. Any doubts? This is the concept why we are considering e power mx as the solution. And if any root is repeated, then we are writing its quotient as quadratic and cubic. And next one, see, any doubts?
No, sir.
Right, now I'm giving the procedure now. Once again I'm listing the procedure to get solution of higher order constant quotient, linear differential equation. Okay, consider Consider the differential equation. What is the form? I will write f of d into y equal to 0. Equation 1. Equation 1. Step 1. Consider the characteristic equation. Consider the characteristic. This is the characteristic equation, or it is also named as auxiliary equation. Auxiliary equation f of m equal to 0. That means what? In f of d, replace d by m and equate it to 0. Second one. Find the roots of f of m equal to 0. Okay. Next, third one. Find the roots of f of m equal to 0. Third one. Case point. If the roots are real and distinct. If the roots are real and distinct, say m equal to m1, m2 and so on, mn. M equal to m1, m2 and so on, mn. Then solution of 1 is y of x equal to, for m1, what I have to write? One constant into e power m1x, one constant into e power m2x, and so on, cn into e power mnx. This is the first point A. Next one, point B. If any root is repeated, if any root is real and repeated, say m equal to m1 repeated 3 times, m2 repeated 2 times, others non-repeated, then solution is y of x equal to, see, m1 repeated how many times? 3 times. So write e power m1x and its quotient as what? Quadratic expression. c1 plus c2x plus c3x square plus m2 repeated how many times? 2 times. Already c3 is over. So c4, c5x linear polynomial, first degree polynomial, e power m2x, and others are non-repeated. Therefore, c6 e power m3x and so on, something lastly, some c star e power mnx, This is the case. First one, real and distinct roots, real and repeated roots. Next one, point C, complex roots. If the roots are complex and distinct, say m equal to some a1 plus or minus ib1, a2 plus or minus ib2 and so on. Some n roots are there. I'm not listing all those. Then solution is y of x equal to, listen carefully, a1 is the real part. First thing, when actually in a plus or minus ib there are 2 roots, a plus ib and a minus ib. So if a plus ib is the root, then its conjugate is also the root. Okay. Now in these 2 roots, a1 plus or minus ib1, a1 is the real part. For real part, you write e power ax. For real part, take real part and write e power ax multiplied by, for this imaginary part b1, you write c1 cosine bx plus c2 sine bx, plus. Now coming to this second, the root is real part is a2, right? E power a2x. For b2, c3 you write cos b2x plus c4 sine b2x and so on. Like this you have to write. This is b1. Like this we have to write. Why I'm writing sines and cosines? The idea is here now, if m equal to a plus or minus ib are the roots, then what is the solution as per our first case, a real and a distinct case? I have to write c1 into some c into, say c into e power a plus or minus ib. This is m1. Let me take, sorry, two roots are there, a plus ib plus c1 into a plus ib plus c2 into a minus ib into x. I have to consider a minus ib into x, isn't it, right? Okay, this is a plus ib into x, a minus ib into x. Then if I simplify this, see c1 into real part e power ax and the imaginary one e power ibx, and this is c2 e power ax and the imaginary one is minus ibx, then real part is common, c1 into e power ibx is nothing but what, cos bx plus I sin bx, plus c2 into what is this, is e power minus I theta cos bx minus I sin bx, right? That is equal to e to the power of ax, and you take cos bx common, then what is this one, c1 plus c2 into cosine bx plus and c1i minus c2i into sin bx, right? Now let me consider c1 plus c2 and this one as a new constant, then what is this, some c1 into cos bx plus c2 into sin bx. This is the solution. So whenever this is the root, whenever a plus or minus ib is the root, what is the solution structure? For real part, write e power ax. For imaginary part, write c1 cos bx plus c2 sin bx. This is the idea behind writing this solution, this one. Now this is what, complex and distinct roots. And finally, complex and repeated. If the roots are complex and repeated, then say m equal to a1 plus or minus ib1, a1 plus or minus ib1, okay, repeated two times, a2 plus or minus ib2, a2 plus or minus ib2, a2 plus or minus ib2, and so on. That means what, this means what, just wait. Where is it? Just wait, word file is gone. Give me a minute. Yeah. Next one, whatever it is. Yeah, if roots are repeated, if the roots, complex roots are repeated, then where it is again, it's gone up. Yeah. Then solution is y of x equal to, same logic. If the roots, this one is repeated 2 times and this root is repeated 3 times. If the root is repeated 2 times, what I have told, wherever constant is there, that means, see, wherever this constant is there, If repeated 2 times means this constant is replaced by first degree polynomial. If it is repeated 3 times, this constant is replaced by second degree polynomial, like that. So using that concept, e power a1x for the first one, e power a1x is the real root. Next one, c1 I have to write, but repeated 2 times, therefore c1 plus c2x into cosine b1x, cosine b1x. And next one, second one is what? Second one is what? This one are again constant. So c3 plus c4x, first degree polynomial into sine bx. This part is regarding to first one, 2 times repeated root. Coming to 3 times repeated root, e power a2x is the real part, 3 times repeated. And coming to 3 times repeated, therefore already c4 is over, c5 plus c6x, c7x square into cosine b2x, same c8 plus c9x plus c10x square into sine b2x, and so on, like this. This is the solution procedure. Any doubts? Any doubts? Any doubts?
No, sir.
Okay. Now, solve this problem. 4y double prime plus 4y prime plus y equal to 0. Solution. First, you have to write operator form of the differential equation. Operator form of the differential equation is 4 into what is it? Y double dash nothing but d square y, 4 first derivative dy plus y equal to 0, where d stands for what? D by dx. D stands for d by dx. So I can take y common here. So 4d plus 1 into y equal to 0. Okay, here what is this is form? F of d into y equal to 0, where f of d equal to what? Where f of d equal to what? 4d square plus 4d plus 1 is homogeneous differential equation. Homogeneous differential equation means I told you this one is equal to 0 in higher order. This is homogeneous differential equation in higher order. Now, what I have to consider? Auxiliary equation. Auxiliary equation is, what is that? F of m equal to 0. F of m equal to 0. So therefore 4m square plus 4m plus 1 equal to 0. Right? So what are the roots? What is this? Yeah, 2m plus 1 whole square equal to 0 I can write. So m equal to negative 1 by 2, negative 1 by 2. Real and repeated 2 times. Repeated how many times? Repeated 2 times. Therefore solution is, what is that? First e power m1 repeated 2 times. E power m1x, that means minus x by 2, and what is its quotient must be? Repeated 2 times means first degree polynomial. First degree polynomial. This is the solution. And next, we solve. Next problem. Y double prime plus 4y prime plus 13y equal to 0, with y of 0 equal to 0, y dash 0 equal to 1. Y dash 0 equal to 1. Solution. Shall I write operator form directly? Let d equal to d by dx. Then given equation can be written in operator form as what is y double dash stands for d square plus 4 into y dash stands for d, 13, y common entirely equal to 0. Equation 1. Here what is f of d? D square plus 4d plus 13. Okay, So characteristic equation or auxiliary equation. Characteristic equation or auxiliary equation. Characteristic equation is f of m equal to 0. That is m square plus 4m plus 13 equal to 0. Factors? No, not possible. So use quadratic expression equation for solution formula minus b plus r minus b square minus 4ac by 2a. b square minus 4ac by 2a. That implies m equal to minus 4 plus r minus how much this is? Yes?
6i.
How much? 6 are 36 are
6i.
6
I,
are
sir.
by 2. That is equal to minus 2 plus or minus 3i. What are the roots? Negative 2 plus or minus 3i3. I3 you write. 3i or I3 doesn't matter. So are complex and distinct. Not repeated, right? Complex and distinct. Complex and distinct. Therefore solution is y of x equal to, I told you a plus or minus ib means what? This is a plus or minus ib. What I told solution? For real part, you write e power x. For imaginary part, not repeated, so you write c1 cos bx plus c2 sin bx. So here what is the solution? Y of x equal to e power minus 2x, c1 cosine 3x plus c2 sin 3x. This is the solution. This is about a problem with the complex roots. Now let me consider higher order equations. All are no higher order at all in this one. Now you solve this problem. Next one, d power 4 y dx power 4 minus a power 4 y equal to 0. Yeah. And the problem is not completed. Some conditions were given in the question. Take this as 2. What is the given? And find y dash also, because condition y dash is also given. So minus 2 into e power minus 2x, c1 cosine 3x plus c2 sin 3x plus e power minus 2x into minus 3c1 sin 3x plus 3c2 cosine 3x. Right? This is equation 3. Given y of 0 equal to how much? 0 is given, right? Therefore, at x equal to 0, 1 implies, that is 2 implies. At x equal to 0, what is y of 0? 0, and this value 1, you will get c1. That's it. This value 0, this value 1, this is 1, c1 value 0. Next, what is the given? Y dash 0 is given as 1. Y dash 0 is given as 1. Therefore, at x equal to 0, equation 3 implies, what is this 3? This part, this is 1 equal to, x equal to 0 means this is minus 2, you will get c1, and here 1 you will get, this is 0, and you will get 3c2 here. Isn't it right? So 1 equal to, what is c1 already? 0. So you will get 3c2. So c2 equal to 1 over 3. C2 equal to 1 by 3, right? Next one. So therefore solution is y of x equal to, substitute these values in the original solution, that is equation 2. c1 value 0, c2 value is there, e power minus 2x by 3 into cosine 3x. Cosine or sine? Sine 3x, I think. C2 value is there, C1 value 0. So this is the answer. Okay, next problem. Solve d power 4 y by dx power 4 minus a power 4 y equal to 0. Solution. I can write what is the operator form. Operator form is d power 4y minus a power 4y equal to 0. So d power 4 minus a power 4 into y equal to 0. Right? This is equation 1. What is the auxiliary equation? Auxiliary equation is f of m equal to 0. That is m power 4 minus a power 4 equal to 0. See, all of you, m power 4 minus a power 4, one can take like this also. M power 4 equal to a power 4. So m equal to a. M equal to a. This is wrong. M power 4 minus a power 4 means fourth degree equation. Fourth degree equation possesses 4 roots. So you have to get 4 roots compulsory. Okay, so this procedure is wrong. So I can write this is m square whole square a square whole square equal to 0. A square minus b square formula. A minus b. This is a value and this is b value into a plus b equal to 0. Then what are the roots? M square minus a square equal to 0. Or m square plus a square equal to 0. So this is m equal to a, m square equal to a square and m square equal to minus a square. Done? So m equal to what are the roots here? Plus or minus a you will get. Here you will get plus or minus ai. Plus or minus ai. Therefore, what are the roots? Therefore, the roots are m equal to minus a plus or minus ai plus ai minus ai. So here the roots are combined. Real roots are there, complex roots are there. Whatever may be, you write the logic. For real roots, you write the solution. Plus for imaginary roots, you write the solution. Therefore, the solution is y of x equal to first one. This is real, not repeated. So c1 into e power minus ax. This is also real, not repeated. So c2 into e to the power of ax plus coming to this. What is this form? 0 plus or minus ia. Real part is 0. Imaginary part is there, not repeated. Therefore, e to the power of 0x. C1, C2 already over. C3, b value is a here. Cos ax plus C4 sin ax. C4 sin ax. Therefore, what is the solution finally? C1 e to the power of minus ax, C2 e to the power of ax, C3 cosine ax plus C4 sin ax. This is the final solution. Right? Now, the problem is now d power 4 y by dx power 4 plus a power 4 y equal to 0. Solution. Operator form of the differential equation is d power 4 plus a power 4 into y equal to 0. Correct? Now what is the auxiliary equation? Or characteristic equation. Characteristic equation is f of m equal to 0. This is f of d. F of d into y equal to 0. You can take small or capital, doesn't matter. So what is this? Is m power 4 plus a power 4 equal to 0. Now tell me the roots. Yes, come on. Anyone? Explain.
Sir, we can write this equation as m power 4 minus a square I whole square.
Yes, come again. M power
4 minus a square I whole square.
Next step.
I'm splitting this as m square minus a square I.
Done. See, m square minus ia square into m square plus ia square, correct?
Yes, sir.
Now next is what? If I consider this as equal to 0, what happens? See, m square minus a square I equal to 0. So m square equal to what? ia square. So m equal to what? Plus or minus root ia, correct?
Yes, sir.
Right? Now, what is the value of I?
-1.
What is the value of I?
Square root of -1.
What is the value of root -1? What is the value of root -1? తెలుగులో చెప్పాలంటే స్క్వేర్ రూట్ ఆఫ్ -1కి దిక్కు లేక వాల్యూ కనుక్కోవడానికి దిక్కు లేక ఇక ఇమాజిన్ చేసుకుందాం అనుకున్నారు దాన్ని. ఇమాజిన్, దట్ ఈస్ వై ఇట్ ఈస్ కాల్డ్ ఇమాజినరీ వాల్యూ. స్క్వేర్ రూట్ ఆఫ్ -1 డజంట్ హ్యావ్ వాల్యూ, దట్ ఈస్ వై వీ హ్యావ్ టేకెన్ ఐ. ఐకే దిక్కు లేనప్పుడు మళ్ళీ స్క్వేర్ రూట్ ఆఫ్ ఐ, రైట్? I has no identity. Square root of I, why square root of I? This is one idea. Okay, one case. So this is not true anymore.
Sir, for m power 4 plus a power 4, add 2a square m square and subtract 2a square m square.
Very good. Now, how you will get that idea? Let us see. So immediately, no one cannot get that idea. So logic is what? You write this is m square whole square. What is your name?
Sir, Sai Sri.
Sai Sri. M square a square whole square, right? We have this formula a square plus b square formula. What is that? A square plus b square formula, a plus b whole square minus a plus b whole square minus 2ab, correct? Is it correct?
Yes, sir.
So using this one, so therefore what I can write this is m square plus a square whole square minus 2ab. A value is what? M square. B value is what? A square. So 2m square a square equal to 0. Now what I can do here, m square plus a square whole square root 2ma I will write and write it as whole square. Write it as whole square. Now this is a, this is b. A square minus b square formula. A square minus b square formula. M square plus a square a minus b. This is minus b. A minus b into a plus b root 2ma equal to 0. So there are two quadratic expressions we are getting. Now I am writing that quadratic expression in what? In what? M. So I will write like this. First equation and the second expression, m square plus root 2a is the constant, m is the way, this is a square equal to 0. So for this, what are the roots? Minus b plus or minus b square minus 4ac by 2a. Next, here m equal to minus b plus or minus b square minus 4ac by 2a, right? So what is this is root 2a plus or minus root 2ai you will get. Is it correct? Here what you will get, m equal to minus root 2a plus or minus minus 2a square means root 2ai you will get by 2. So finally what are the roots? Therefore roots are, I will write m equal to take 2a by root 2 plus ia by root 2. The first case plus or minus this part. Let us divide 2. This is a by root 2 plus or minus ia by root 2. Ia by root 2. Here also minus a by root 2 plus or minus ia by root 2. So another is minus a by root 2 plus or minus ia by root 2. Ia by root 2. These roots are complex or complex repeated? Repeated or not repeated? Not repeated. Therefore solution is y of x equal to, first for the first part, real part, e power a by root 2x. For the imaginary part, c1 cos bx. B means this, c2 sin bx, plus for the second case, real part is this, so e to the power of minus a by root 2x, and c1 c2 over c3 cos a by root 2x plus c4 sin a by root 2x. This is the solution. Any common in this solution? Any common? This is not common. Remember, constants are different. C1, C2 here, C3, C4 here. Right? Keep the solution as it is. Any doubts? Any doubts?
No, sir.
అంటే నిన్ననే ఎస్టర్డే ఐ సా వన్ మీమ్ అంటే ఏదో నాకు తెలియదు, మా పిల్లలు చూపించారు. సార్ క్లాస్ చెప్తా ఉన్నాడు. సార్ ఈజ్ టెల్లింగ్ క్లాస్. ఈజ్ ఇట్ అండర్స్టూడ్? ఎనీ డౌట్స్ ఈ షౌటింగ్. నోబడీ ఈజ్ గివింగ్ రిప్లై. Then is it audible? He is asking. Nobody is replying. Oh, class session is over, you can quit. Then all are quit. Then he understood, yes, audio is working. So please give me reply so that I can understand you are getting doubts or not. No reply.
No doubts, sir.
No doubts. Next. You want more problems in this, or shall I go for next one? Now take some assignment problems. Solve d square plus d plus 1 whole square into d minus 2 into y equal to 0. This directly operator form is given directly, so no need to bother. Y equal to 0. Directly you write f of d, then f of m, auxiliary equation. D power 4 y by dx power. Whenever order is there, fourth order means you must get 4 roots. Plus 16y equal to 0. D power 4y by dx power 4 minus 4y equal to 0. D cube minus 6d square plus 11d minus 6 into y equal to 0. D power 4 plus 18d square plus 81 into y equal to 0. Next one and the last one. D power 4, yeah, I have given na 4d power 4 minus 8d cube minus 7d square plus 11d plus 6 into y equal to 0. And the last one, d cube plus d square plus 4d plus 4d plus 4 into y equal to 0. D cube plus 1 into y equal to 0. D power 4 minus 4d plus 4 into y equal to 0. In this, just let me explain the sixth problem. See, what is the sixth one? D power 4 plus 18d square plus 81. I am giving fastly. What is the auxiliary equation? Auxiliary equation is f of m equal to 0. That means m power 4 plus 18 m square plus 81 equal to 0. What are the any factorization? 9 is there. M square plus 9 I will get. Whole square equal to 0. Correct? Done. Right. That means what? M square plus 9 equal to 0. M square plus 9 equal to 0. So m square equal to minus 9. M square equal to negative 9. So m equal to what? M equal to plus or minus I3. And here also plus or minus I3. Complex and repeated. Complex and repeated. Totally how many roots? 4 roots I got, right? Complex and repeated how many times? 2 times. Therefore solution is yx equal to, there is no real part. Real part is 0. So e power 0x. 2 times repeated means instead of c1, I have to write first degree polynomial into cosine 3x plus, and same thing, c3 plus c4x. Instead of c2, I have to write this sine 3x. That's it. This is the solution. E power 0x value 1. So c1 plus c2x into cosine 3x. This is one example for complex and repeated roots. Sine 3x. Right? This is the topic. What is this topic? Constant quotient homogeneous. Constant quotient homogeneous differential equation. Linear, particularly linear. In the next class, non-homogeneous means right side function is not 0. Right side function not 0 means this is not 0. Some function will be there. That is called non-homogeneous constant quotient linear differential equation. Then how to solve that problem? I will stop here. Any doubts?
No, sir.